Hello, welcome to this session of kind of revision. So today we'll be looking at the basic computer architecture and the different kinds of programming languages which are available as a part of software. Okay, so even though you might have seen or discussed all these things, so which I am going to teach you in the beginning for first half an hour or so. So that will act as an introductory session for what we are going to discuss in detail later. So today we will see the black box architecture of how a computer look like, okay, followed by the actual details of the inner components. Okay, I am not going to give exactly in complete details of the box which you are going to see on your desktops, but I am going to see I am going to give you a kind of different components which are present basically inside a box to be called it as a computer. So for that, let's begin by defining how a computer might look like. You might have seen this diagram in various kinds of form earlier. So this is what I am going to put it in a simple black box kind of an architecture it is actually, because I am not going to reveal any of the inner parts over here. So towards the end of the session we will discuss actually what is present inside the CPU, which is sitting at the center of this computer architecture. So basically to define it as an entire computer system, so you should be having these four components, then only it can be called as a complete computer. You may be finding this architecture in various different formats. So the first one will be input, okay, and the first and foremost would be, you can consider it as a central processing unit. So it was central processing unit, you cannot do anything, it is the heart of the computer. So central processing units around which we are going to define many peripherals. ಅದು ಸೆಂಟ್ರಲ್ ಇರುತ್ತೆ, ಅದು ಸುತ್ತ ನಾವು ಪೆರಿಫೆರಲ್ಸ್ನ ಜೋಡಿಸ್ಕೊಳ್ತೀವಿ. ಆ ಪೆರಿಫೆರಲ್ಸ್ ಯಾವುದು ಅಂದರೆ ಇನ್ಪುಟ್ ಆಗಿರ್ಬೋದು, ಔಟ್ಪುಟ್ ಆಗಿರ್ಬೋದು, ಅಥವಾ ಮೆಮೊರಿ ಆಗಿರ್ಬೋದು. So okay, this CPU mainly consists of something called as microprocessor. Okay, you might have been hearing microprocessor starting from 4004, which has been released in 1971. So till today you might have seen that Pentium hyperthread, Pentium dual core, Pentium core duo processors. Okay, these are all they actually will be present in CPU. Okay, so around that you are going to have the first one is input devices. Why do we call it as input devices? We are taking the information from these devices into the computer, that's why they are called as input devices. Okay, we may be supplying the information in the form of by typing the characters in the form of okay, keyboard. So then we can send some signals in the form of mouse. When we move the mouse, this that will be converted into horizontal and vertical coordinates, and computer software is going to process it, and you are going to get the cursor at the screen whichever position you want. Okay, followed by a joystick. Okay, joystick is something like most probably it is used to play games. Okay, instead of having keyboard and mouse, ಅದನ್ನು ಕೂಡ ಯೂಸ್ ಮಾಡ್ಬೋದು ನಾವು ಗೇಮ್ಸ್ನ ಪ್ಲೇ ಮಾಡೋಕ್ಕೆ. ಬಟ್ ಸಮ್ ಹೈ ಎಂಡ್ ಗೇಮ್ಸ್ ಅಂದರೆ ತುಂಬ ಸೊಫಿಸ್ಟಿಕೇಟೆಡ್ ಗೇಮ್ಸ್ ಇದೆ, ಅದನ್ನೆಲ್ಲ ಆಡಲಿಕ್ಕೆ ಜಾಯ್ಸ್ಟಿಕ್ ಯೂಸ್ ಮಾಡೋದು ಒಳ್ಳೆಯದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈ ಜಾಯ್ಸ್ಟಿಕ್ ಎಲ್ಲ ಎಲ್ಲಿ ಯೂಸ್ ಅಪ್ ಮಾಡ್ತಾರಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, ನಿಮಗೆ ಡ್ರೈವಿಂಗ್ ಕಲಿಸ್ಕೊಡ್ಲಿಕ್ಕೆ. ಯು ನೀಡ್ ನಾಟ್ ಟು ಗೋ ಟು ಆ್ಯಕ್ಚುಯಲ್ ಕಾರ್, ಡ್ರೈವ್ ಇಟ್ ಆನ್ ದ ರೋಡ್ ಆ್ಯಂಡ್ ಹ್ಯಾವ್ ದ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್. So what you will be entering into something called as virtual reality, so wherein which you are sitting in front of a big screen. So ಆ ಸ್ಕ್ರೀನಲ್ಲಿ ನಿಮಗೆ ರೋಡು, ಆ ಕಡೆಯಿಂದ ವೆಹಿಕಲ್ಸ್, ಓಕೆ, ಹಿಂದ್ಗಡೆಯಿಂದ ವೆಹಿಕಲ್ಸ್ ಎಲ್ಲ ಸೇಮ್ ನೀವು ರೋಡಲ್ಲಿ ಯಾವ ಥರ ಡ್ರೈವ್ ಮಾಡ್ತೀರಾ ಅದೇ ಥರ ಬರ್ತಾ ಇರುತ್ತೆ. ನೀವು ಮುಂದ್ಗಡೆ ಜಾಯ್ಸ್ಟಿಕ್ ಇರುತ್ತೆ, ದಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಮಚ್ ಸಿಮಿಲರ್ ಟು ಯುವರ್ ಕಾರ್. ಇದು ಆ ಕಾರ್ ಇದು ನೀವು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಡ್ರೈವ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ರೆ, ಸೊ ನೀವು ಬ್ರೇಕ್ ಹಾಕಿದ್ರೆ ಸೇಮ್ ಕೈಂಡ್ ಆಫ್ ಎಫೆಕ್ಟ್ ಸಿಗುತ್ತೆ. ಸೊ ಅದನ್ನು ಜಾಯ್ಸ್ಟಿಕ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಸಮ್ ಹೈ ಎಂಡ್ ಗೇಮ್ಸ್ ಲೈಕ್ ಕ್ವೇಕ್ ಅಂತ ಇದೆ, ಅವನ್ನೆಲ್ಲ ಪ್ಲೇ ಮಾಡಲಿಕ್ಕೆ, ಶೂಟ್ ಮಾಡಲಿಕ್ಕೆ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ದಟ್ ಗನ್ಸ್ ಇನ್ ಯುವರ್ ಹ್ಯಾಂಡ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಆ್ಯಂಡ್ ಶೂಟ್ ಇಟ್ ಅಟ್ ದಿ ಮಾನಿಟರ್. ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ಬುಲೆಟ್ಸ್ won't come out of that, but that whenever you shoot, that signals will be sent to the wire into the computer as a bullet, and you are going to shoot the person in front of you on the monitor. So they are called as joysticks. I am going to show you how joysticks are. You might have already seen them. Then apart from that you have something called as stylus. These stylus are actually used with one kind of computers which are having touch screen. Okay, what do you mean by touch screen? So ನಿಮ್ಮ ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ ಏನೋ ಇನ್ಫಾರ್ಮೇಷನ್ ಬರ್ತಾ ಇರುತ್ತೆ. ಸೊ ಯೂಸಿಂಗ್ ದಟ್ ಸ್ಟೈಲಸ್ ವಿಚ್ ಲುಕ್ಸ್ ಲೈಕ್ ವೆರಿ ಮಚ್ ಸಿಮಿಲರ್ ಟು ಎ ಪೆನ್, you click on certain portion of one portion of the monitor, you are going to get that function get activated. Okay, ಆ ಥರ ಇವಾಗ ನೀವು ಮೌಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರಿ. Okay, you use the mouse and you click an icon ಅಂದರೆ it's a kind of graphic image which is present on your desktop is nothing but the place where in which you are going to place those icons. Okay, ಅದ್ರ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ there is a word processor icon which is represented by W. ಓಕೆ, ಸೊ ಅದ್ರ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿದ ತಕ್ಷಣ ವರ್ಡ್ ಪ್ರೊಸೆಸರ್ ಓಪನ್ ಆಯಿತು. ಅದನ್ನು ಮೌಸಲ್ಲಿ ಕೂಡ ಮಾಡ್ಬೋದು. ಅದ್ರ ಬದಲು ಸ್ಟೈಲಸ್ ತೊಗೊಂಡು ಇಫ್ ಯುವರ್ ಮಾನಿಟರ್ ಇಸ್ ಟಚ್ ಸ್ಕ್ರೀನ್, ಆ ಸ್ಟೈಲಸ್ನಲ್ಲಿ ಲೈಟಾಗಿ ಟಚ್ ಮಾಡಿದ್ರೆ the same functionality it's going to implement. The word processor start agute, you can start typing. This is called as stylus. Okay, so there are various kinds of input devices. Like one more example if you want me to take, there is a scanner. Okay, you have some pictures with you in the form of hard copy, so that you can put on the scanner, you can scan it. And sometimes what happens is you want to present some information which is inside the book. There are hundreds of lines and you have very less time and you have to go and present it at the short notice. So at that time what you can do is you can even scan the book also. It is going to read the contents of the book in the form of text lines, and that can be saved in the form of a word document, and you can take it and as well as you can give the presentation. ಅಂದರೆ ಮುಂಚಿನ ಥರ ನೀವು ಕೂತ್ಕೊಂಡು ನೋಟ್ಸ್ ಮಾಡೋದು, ಒಂದು ಜೆರಾಕ್ಸ್ ಮಾಡಿಸೋದು ಆ ಥರ ಏನು ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಒಂದು ಬುಕ್ ತೊಗೊಂಡು ಈವನ್ ಡಾಕ್ಯುಮೆಂಟ್ ಕೂಡ ನೀವು ಜೆರಾಕ್ಸ್ ಮಾಡಿ ನಿಮ್ಗೆ ಇಷ್ಟ ಬಂದ ಥರ ಮಾಡಿಫೈ ಮಾಡ್ಕೊಳ್ಬೋದು. ಸೊ ಓಕೆ, ದೀಸ್ ಆರ್ ಆಲ್ ದ ವೇರಿಯಸ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಇನ್ಪುಟ್ ಡಿವೈಸಸ್ ವಿಚ್ ಕ್ಯಾನ್ ಬಿ ಕನೆಕ್ಟೆಡ್ ಟು a typical computer. Okay, then as usual you have CPU as I told you, which will be comprising as microprocessor as the main element. Okay, the microprocessor will be basically consisting of two components. One is called as arithmetic and logical unit and the other one is called as control unit. So most of the time we are going to use microprocessor for doing some of arithmetic and logical computation that will be taken care by arithmetic and logical unit. Okay, so then you don't want the answer to be given one day or 1 hour afterwards. Okay, after you have given the question. So therefore there should be something called as some control unit which is going to coordinate the activities. ನೀವು ಇನ್ಪುಟ್ ಕೊಟ್ಟಾಗ ಎಷ್ಟೊತ್ತಲ್ಲಿ ಔಟ್ಪುಟ್ ಬರಬೇಕು, ಯಾವಾಗ ಔಟ್ಪುಟ್ ಬರಬೇಕು, ಆ ಥರ ಎಲ್ಲ ಕೋಆರ್ಡಿನೇಷನ್ ಮಾಡೋಕ್ಕೋಸ್ಕರ ಒಂದು ಯೂನಿಟ್ ಇರುತ್ತೆ. ಸೊ ಇಟ್ ಈಸ್ ಲೈಕ್ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಆಸ್ ಎ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಎನ್ ಆರ್ಗನೈಸೇಷನ್ ಇಫ್ ಯು ಟೇಕ್ ಎನ್ ಎಜುಕೇಷನಲ್ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್. ಅಂದರೆ ಆ ಪ್ರಿನ್ಸಿಪಲ್, ಇವಾಗ ವೇರಿಯಸ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಸ್ ಇರುತ್ತೆ. ವಿ ಕಾಂಟ್ ಸೇ ದಟ್ ದ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಸ್ ಕೆನಾಟ್ ವರ್ಕ್ ಆನ್ ದೇರ್ ಓನ್. ಓಕೆ, ಆ್ಯಂಡ್ ದೇರ್ ಶುಡ್ ಬಿ ಎ ಪ್ರಿನ್ಸಿಪಲ್ ಆ್ಯಂಡ್ ಆಲ್. ಸೊ ವೈ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಇಸ್ ದೇರ್ ಆ್ಯಕ್ಚುಲಿ ಈಸ್ ಎಲ್ಲ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅದೇ ಆದ ಪಾಲಿಸಿ ಇರುತ್ತೆ. ಅವನ್ನೆಲ್ಲ ಒಂದು ಕಡೆ ಸಿಂಕ್ರೊನೈಸ್ ಮಾಡಿ ಎಲ್ಲ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಗಳು ಒಂದು ಥರ ಕಮ್ಯುನಿಕೇಷನ್ ಎಸ್ಟಾಬ್ಲಿಷ್ಮೆಂಟ್ ಮಾಡೋಕ್ಕೋಸ್ಕರ you should be having one head of the institution and he will be called as the CPU, and he will periodically you will be issuing some signals. ಓಕೆ, ಯಾವುದೇ ಆರ್ಗನೈಸೇಷನ್ ತೊಗೊಳ್ಳಿ, ಅದರಲ್ಲಿ ಒಬ್ಬರು ಹೆಡ್ ಅಂತ ಇದ್ದೇ ಇರ್ತಾರೆ. ಅವ್ರ ಮೇನ್ ಜಾಬ್ ಏನಾಗಿರುತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲ್ಲ ಆ್ಯಕ್ಟಿವಿಟೀಸು ಕರೆಕ್ಟಾಗಿ ನಡೀತಿದೆಯಾ, ದೇರ್ ಶುಡ್ ಬಿ ಒನ್ ಪರ್ಸನ್ ಆಲ್ವೇಸ್ ಟು ಮಾನಿಟರ್, isn't it? and it comes by experience. Okay, so you cannot say that I can also do that kind of work. It's very difficult. You can do the work, but actually managing the work, that means getting the work done by some other person, will be very difficult. That is what our management courses teach. And we need the control unit is mainly responsible for generating the signals which are going to synchronize the activities of various components inside the microprocessor. Control unit to periodically signals na generate ಮಾಡಿ ಎಲ್ಲ ಕಾಂಪೊನೆಂಟ್ಸು ಒಂದಾದ್ಮೇಲೆ ಒಂದು ವರ್ಕ್ ಮಾಡೋ ಥರ, ಜೊತೆಲಿ ವರ್ಕ್ ಮಾಡೋ ಥರ ನೋಡ್ಕೊಳ್ಳುತ್ತೆ. ಓಕೆ, ಅಟ್ ದಿ ಔಟ್ಸೆಟ್. Okay, then you have output. That means you have microprocessor as well as you have fed in some information into the microprocessor. Some process has been done. So what is the use if you cannot see what's happening exactly? So ಏನಾಯಿತು, ನೀವು ಎರಡು ನಂಬರ್ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ರಿಸಲ್ಟ್ ತೋರಿಸ್ಬೇಕಲ್ವಾ. at least when you enter the number, those two numbers should be present on the screen. So ಎಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಆಗಿರಬೇಕು ಅದನ್ನೆಲ್ಲ ಔಟ್ಪುಟ್ ಡಿವೈಸಸ್ ನೋಡ್ಕೊಳ್ತವೆ. Output device, as the name itself suggests, take the output from the microprocessor and display it to the user. User ಅಂದರೆ ನೀವು ಅಥವಾ ನಾವು ಯಾರೇ ಆಗಿರ್ಬೋದು. So there are various kinds of output devices. The first and foremost output device is a monitor. Computer monitor ನೀವು ನೋಡೇ ಇರ್ತೀರಾ. I am going to show you various kinds of monitor that are present, as well as printer. Sometimes you are going to edit the document, and after editing the document you want to show it to some, or you edited the letter and you have to give the letter, you have to send the letter to someone else. You cannot most of the time you prefer to use emails, where in which printout is not necessary, but sometimes you want to send it by snail mail, that's through the post office, then you have to take the printouts, that can be done using printer. So that's also a print output device. Similarly, you have projector. What do you mean by projector? Instead of connecting the computer to a monitor, you can connect it to a projector and project it on the wall, okay, so that everybody can see a big picture, everybody can have a big view of what you want to demonstrate. They are called as LCD projector. Basically these LCD projectors are used to give a demo, okay, or you want to give a presentation, okay, where hundreds and tens of hundreds of people will be present, so they are called as output devices. So like that you have many other output devices. Then so there should be something to store the information, isn't it? You are feeding in the information to the computer. The computer has got a very limited memory. What do you mean by computer? Here is the microprocessor. It has got very limited memory. So ಅದಕ್ಕೋಸ್ಕರ ನೀವು ಎಕ್ಸ್ಟ್ರಾ ಮೆಮೊರಿನ ಕಂಪ್ಯೂಟರ್ಗೆ ಆ್ಯಡ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ ಎಕ್ಸ್ಟ್ರಾ ಮೆಮೊರಿ ಕ್ಯಾನ್ ಬಿಕಮ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪ್ರೈಮರಿ, ಸೆಕೆಂಡರಿ ಆಸ್ ವೆಲ್ ಆಸ್ ಟರ್ಷರಿ, ವಾಟ್ ಯು ಕಾಲ್ ಇಟ್ ಆಸ್ ನೌ-ಎ-ಡೇಸ್ ಪೆನ್ ಡ್ರೈವ್ಸ್. okay, so adella neevu use ಮಾಡಬಹುದು. I am going to give a demo of how they look like actually. Okay, so this is the typical view of a computer system. It comprises of one input device, it comprises of two input devices actually. So one is keyboard, the mouse, then two output devices, monitor and the printer, and it has got some storage devices also. So as I told you, you can have fixed as well as movable disks. So movable disk means you can keep it outside the computer, you can store the information and take it wherever you want. So it has got and as well as one CPU also. So this is a typical view of a basic computer, and you are going to find this picture most often. Nowadays this picture is getting replaced by newer very thin monitors, very thin CPUs, and keyboards will be very compact and beautiful, and the mouse you won't find something called as wires which are connected, they are called as cordless mouse. Okay, then you may be finding along with this one web camera, wherein which you can record your sessions, as well as you may find some multimedia speakers, wherein which you can when you are watching movie through the computer, you can hear sound, you can listen to MP3 music and all. So this picture is totally absurd. Nowadays you are going to find highly sophisticated computer, as I was explaining you some days back. By paying just a cost of 15 to 20,000 rupees, you are going to get a highly sophisticated, very high speed working computers. Okay, so then basically when we talk about computers, we will talk about two terminologies. One is called as hardware and software. Okay, what are these hardware and software? Okay, hardware means don't think about the hardware which you are going to get in that iron shop. I am talking in with respect to the computers over here. What do you mean by computer hardware? You might have seen many hardware shops, okay, in many places, in many places, computer hardware shop, where they are going to sell something. That's what I call it as physically touchable. Okay, hardware part of a computer is something wherein which you can actually see them, you can touch them and feel them. Okay, a monitor is an hardware, a keyboard is a hardware, okay, a mouse is a hardware, something like that. So they are called as hardware. And given an example like input devices are hardwares, output devices are hardwares, and like keyboard, mouse, scanner are input devices, monitor, LCD projectors and printers are called as output devices. So when we come to printers, actually we have basically three kinds of printers. I am going to show the pictures of them actually. The first and the foremost one was a line printer actually. The line printer used to print pages at the rate of 10 pages per minute some kind. Then afterwards they identified, they found actually dot matrix printer. So dot matrix printer ಅಂದ್ರೆ ಹೇಳಿದ್ರೆ ನಿಮ್ಮ ಟೈಪ್ರೈಟರ್ ಅಲ್ಲಿ ಟೈಪ್ ಮಾಡಿದಾಗ ಯಾವ ತರ ಕ್ಯಾರೆಕ್ಟರ್ಸ್ ಬರುತ್ತೋ ಅದೇ ತರ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಓನ್ಲಿ ದಿ ಡಯಾಗ್ರಾಮ್, ಯು ಕುಡ್ ಹ್ಯಾವ್ ಟೇಕನ್ ಓನ್ಲಿ ದ ಡಾಕ್ಯುಮೆಂಟ್ಸ್. ಡಯಾಗ್ರಾಮ್ ತಗೊಂಡ್ರೆ ಅದು ಅಷ್ಟು ಚೆನ್ನಾಗಿ ಕಾಣಿಸ್ತಿರಲಿಲ್ಲ ಡಾಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಪ್ರಿಂಟಲ್ಲಿ. ಅದು ಆಸ್ ದ ನೇಮ್ ಇಟ್ ಸೆಲ್ಫ್ ಸಜೆಸ್ಟ್, ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರಿಂಟ್ ದ ಡಾಕ್ಯುಮೆಂಟ್ ಬೇಸ್ಡ್ ಅಪಾನ್ ದ ಡಾಟ್ಸ್ ಆ್ಯಕ್ಚುಲಿ. ದೇ ಪುಟ್ ಎ ಡಾಟ್ ಆ್ಯಂಡ್ they are used to be visible like dots only. Okay, so they are called as dot matrix printer. Then later they invented something called as inkjet printer, in which inkjet printer ಅಂದರೆ ಅದರಲ್ಲಿ ಒಂದು ಕಾರ್ಟ್ರಿಜ್ ಅಂತ ಹಾಕ್ತೀವಿ. ಸೊ ಆ ಕಾರ್ಟ್ರಿಜಲ್ಲಿ ಲಿಂಕ್ ಇರುತ್ತೆ. ಸೊ ವಾಟ್ ಎವರ್ ದ ಇನ್ಫಾರ್ಮೇಷನ್ ಇಟ್ ಇಸ್ ರಿಸೀವಿಂಗ್ ಫ್ರಮ್ ದ ಕಂಪ್ಯೂಟರ್, ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಕಲರ್ ಇಟ್ is going to print on the page. So the inkjet printer used to be very costly. Okay, the printouts which you are going to take used to be very costlier in inkjet printer. That's why they invented bit low cost printers which are called as laser jet printers. In laser jet printer actually you can take hundreds or thousands of pages using only single cartridge, but most of the time nowadays they have developed even color laser jet printers. But earlier when they identified when they discovered this laser jet printer, they used to work with only black and white data. Okay, so they are very much faster compared to your inkjet. Your inkjet may take for example 30 seconds for a printout, one document which is containing one page, having some full page of information, but whereas if you give it, it is going to give you within a matter of 2 or 3 seconds. So laser jet printers work very faster when compared to the inkjet printers. Okay, so then memories actually. So memories can be classified as primary and secondary memory. So which are the primary memory, which are secondary memory? So apart from this you have one more kind of memory which is called as processor memory. The processor memory will be inside the microprocessor, and ಇವೆಲ್ಲ ಬೇರೆ ಬೇರೆ ಟೆಕ್ನಾಲಜಿ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡ್ತಾರೆ. ಪ್ರಾಸೆಸರ್ ಮೆಮೊರಿ ಏನಾಗುತ್ತೆ, ಪ್ರಾಸೆಸರ್ ಒಳಗಡೆನೆ ಸಮ್ ಕೈಂಡ್ ಆಫ್ ಮೆಮೊರಿ ಇರುತ್ತೆ, ಅದನ್ನ ರಿಜಿಸ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Okay, a register you cannot have hundreds and thousands of registers inside a microprocessor because of the space limitation. Microprocessor and ಎಷ್ಟಿರುತ್ತೆ 2 inches by 2 inches ಇರುತ್ತೆ ಮ್ಯಾಕ್ಸಿಮಮ್, ಅಥವಾ 3 inches by 3 inches ಇರುತ್ತೆ ಆ ಥರ. ಸೊ ಅದರಲ್ಲಿ ನೀವು ಜಾಸ್ತಿ ಮೆಮೊರಿ ಇನ್ಕ್ಲೂಡ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಸೊ ಯು ಮೇ ಬಿ ಹ್ಯಾವಿಂಗ್ ಎ ಮ್ಯಾಕ್ಸಿಮಮ್ 24 registers. ಓಕೆ, ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಆ್ಯಂಡ್ ಅದೇ ಪ್ರಾಸೆಸರ್ ಟೆಕ್ನಾಲಜಿ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇನ್ನೂ ಮೆಮೊರಿ ಇದು ಮಾಡಿದ್ರೆ ತುಂಬ ಕಾಸ್ಟ್ಲಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ವಾಟ್ ವಿ ವಿಲ್ ಡೂ ಇಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ದ ಮೆಮೊರಿ ಇನ್ 3 different kinds of technologies. So one is called as processor memory, the other one is called as primary, the other one is called as secondary memory. What are these processor, primary and secondary memory? Let us discuss now. Okay, the primary memories are once again classified into two. The first one is called as RAM, the second one is called as ROM. RAM stands for actually random access memory. ROM stands for read only memory. ROM is also sometimes, RAM is most of the time referred to as worms. What do you mean by worms? Write once and read many times memories. Why we call it as write once and read many times memories? In ROM, once the information is stored, it's very difficult to change the information, whereas in RAM the information will be stored as well as they will be deleted in a fraction of a second. Once again you can fill it up with a new kind of information, so they are called as RAM. Whereas ROM, earlier when they invented ROM, it was very difficult to delete the contents of a ROM. Nowadays they have devised the ROM in such a way that you can erase the contents and you can put the original content, but that is not going to be done most often. ಪದೇ ಪದೇ ಮಾಡಲ್ಲ in read only memories ನಲ್ಲಿ. But whereas in random access memory, it is meant to be accessing the memory location in random. So obviously you will be keep on entering the information at the same, and you will be keep on deleting the information. So and once again RAM can be classified as, that is random access memory can be classified into two parts. One is called as static RAM, the other one is called as dynamic RAM. What do you mean by static RAM? ನೀವು ಇನ್ಫಾರ್ಮೇಷನ್ ಸ್ಟೋರ್ ಮಾಡೋದು, so that will be there permanently until the power is switched off. Okay, once you switch off the power, then whatever the information you have stored in static RAM will erased off. So whereas in dynamic RAM, the information will be stored in the form of electrical charges and capacitors. So in capacitor property ನಿಮಗೆ ಗೊತ್ತೇ ಇರುತ್ತೆ, ಬೇಸಿಕ್ ಸೈನ್ಸಸ್ ಅಂದರೆ ನೀವು ಓದೇ ಇರ್ತೀರಾ. ದೇ ಆರ್ ದಿ ಟೆಂಡೆನ್ಸಿ ಆಫ್ ಗೆಟಿಂಗ್ ಡಿಸ್ಚಾರ್ಜ್ಡ್. ಸ್ವಲ್ಪ ಒಂದು ಕೆಪಾಸಿಟರ್ನ ಚಾರ್ಜ್ ಮಾಡಿ ಆ ಕಡೆ ಬಿಸಾಕಿದ್ರೆ ಸ್ವಲ್ಪ ಹೊತ್ತಿಗೆ ಅದು ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿಬಿಟ್ಟಿರುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಯು ನೀಡ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಎಸ್ ರಿಫ್ರೆಶ್ ಲಾಜಿಕ್. ಸೊ ಆ ರಿಫ್ರೆಶ್ ಲಾಜಿಕ್ನ ಬಿಲ್ಡ್ ಮಾಡೋ ರ್ಯಾಂಡಮ್ ಆಕ್ಸೆಸ್ ಮೆಮೊರಿಗಳನ್ನ ನಾವು ಡೈನಮಿಕ್ ರ್ಯಾಂಡಮ್ ಆಕ್ಸೆಸ್ ಮೆಮೊರೀಸ್ ಅಂತ ಕರಿತೀವಿ. Okay, so then in ROM technology we have different kinds of ROM. Earlier there was a programmable read only memory, that's what we call it as PROM. In PROM what used to happen is once you write the information, it was very difficult to delete from that. Okay, so there was no means by which you could have deleted it. They are called as programmable ROMs. Then after that, so people started thinking like, before the actual code has been deployed into the ROM, so it has to be changed many times, but ಅದನ್ನ ಟೆಸ್ಟ್ ಮಾಡದೆ ನಾವು ಮತ್ತೆ ಚೇಂಜ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. once we test by putting it into ROM, then only we come to know there should be some errors and it should be get changed. ಸೊ ಅವಾಗ ರಾಮ್ನ ಪೂರ್ತ ನಾವು ಬಿಸಾಕಬೇಕಾಗಿತ್ತು. ವಿ ಶುಡ್ ಹ್ಯಾವ್ ಬೀನ್ ಇನ್ ಎ ಪೊಸಿಷನ್ ನಾಟ್ ಟು ಯೂಸ್, ಐ ಮೀನ್ ಅದನ್ನು ಯೂಸ್ ಮಾಡೋಕ್ಕಾಗ್ತಿರ್ಲಿಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡಿದ್ರು, ಎರೇಸಬಲ್ ಪ್ರೋಗ್ರಾಮೇಬಲ್ ರಾಮ್ನ ದೇ ಐಡೆಂಟಿಫೈಡ್, ವೇರ್ ಇನ್ ವಿಚ್ you can write the information and you find that it's not working properly, then you put them under something called as UV radiation boxes. UV radiation ಅಂತ ಹೇಳಿದ್ರೆ ಒಂದು ಟ್ಯೂಬ್ಲೈಟ್ ಇರುತ್ತೆ, ಅದು UV ರೇಡಿಯೇಷನ್ ಎಮಿಟ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ, ಆ ಬಾಕ್ಸ್ ಒಳಗಡೆ ಇರುತ್ತೆ. ಅದನ್ನು ರಾಮ್ ಇಟ್ಟರೆ ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ ದಿ ಇನ್ಫಾರ್ಮೇಷನ್ ಯೂಸ್ ಟು ಗೆಟ್ ಎರೇಸ್ಡ್ ಆಫ್. ದೀಸ್ ಆರ್ ಕಾಲ್ಡ್ as electrically programmable read only memories. Then after that you have electrically erasable prompts or electrically alterable programmable random. So here there is a spelling mistake over actually. Electrically alterable programmable random memories, okay, read only memories. So what happens here is as I told you, so ivaga ನೀವು the difference between erasable programmable read only memory and electrically alterable programmable read only memory is that you should physically remove the EEPROM, keep it under UV rays so that you are going to erase the information off. But sometimes what happens, you would have integrated that EEPROM on the motherboard itself. At the time removing the EEPROM from the motherboard, erase it, write the new information and keep it back would have been very difficult. So can we program the EEPROM whenever it is on the motherboard? So is it possible? So they later they identified these electrically alterable or electrically erasable programmable read only memories. So aವಾಗ ಏನಾಗುತ್ತೆ, you can put them, let them be staying wherever they are, from there only I can delete the information and read the information. They are called as electrically alterable programmable read only memories. Okay, so this is the primary memory actually. So when you come to fixed memory, when you come to secondary memory, so these primary memories are very costly memories, in the sense they will cost 1 GB of RAM may cost 1,500 rupees, something like that. Okay, so and so how much memory you can afford to buy? So if you want to store some 100 gigabytes of information, you have to pay some 1.5 lakhs, but that information might not be used very much often. So these primary memories are basically used to store the information which will be often needed by the microprocessor. So ಹಂಗಾದ್ರೆ ನಾವು ಅವಾಗ ಯೂಸ್ ಮಾಡೋದು ಇನ್ಫಾರ್ಮೇಷನ್ನ ಎಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡಿಡೋದು? ಸೊ ವಿ ಮೇ ನಾಟ್ ನೀಡ್ ಇಟ್ ಫಾರ್ ದಿ ಟೈಮ್ ಬೀಯಿಂಗ್, ಬಟ್ ವಿ ನೀಡ್ ಇಟ್ ಇನ್ ಫ್ಯೂಚರ್. ಡೆಫಿನೆಟ್ಲಿ ವಿ ಮೇ ನೀಡ್ ಇಟ್ ಇನ್ ಫ್ಯೂಚರ್. ಅದಕ್ಕೋಸ್ಕರ ಸೆಕೆಂಡರಿ ಮೆಮೊರಿ ಅಂತ ದೇ ಐಡೆಂಟಿಫೈ. So the secondary memory actually can be divided into two. One is called as fixed memories, the other one is called as movable secondary memories. In fixed memories, if you want me to take an example, ivaga hard disk and a floppy drive, they are all fixed, and a CD-ROM drive, they are all fixed memories actually. Andre now adina computer fix mabitirtivi, you may not be able to, even though it is possible to remove them, take it to another computer and fix it, may not prefer to do it. So that's why they are called as fixed secondary memory devices, wherein which in movable devices you will be having magnetic tapes. Okay, you will be having, actually floppy disk is actually movable, whereas floppy drive is immovable. Okay, so that difference you have to make it. CD drive is actually immovable, whereas the CD which you are going to use inside, that will be movable. So then we have pen drives, what we call it as flash drives nowadays, they are all called as movable secondary devices. They are basically used to store huge amounts of information which are not often needed by the microprocessor to work with. Okay, ಇವಾಗ ಮೈಕ್ರೋಪ್ರೊಸೆಸರ್ ಯಾವುದರಲ್ಲೋ ಒಂದು ಪ್ರೋಗ್ರಾಮಲ್ಲಿ ವರ್ಕ್ ಮಾಡಬೇಕು, ದಟ್ ಶುಡ್ ಬಿ ದೇರ್ ಇನ್ ಸಮ್ ಮೆಮೊರಿ ಲೊಕೇಶನ್, ದಟ್ ಮೆಮೊರಿ ಲೊಕೇಶನ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಪ್ರೈಮರಿ ಮೆಮೊರಿ ಲೊಕೇಶನ್. ವೆರಾಸ್ ನಾಳೆ ಒಂದು ಯೂಸ್ ಮಾಡಬೇಕು, ಬಟ್ ರೈಟ್ ನೌ ಇಟ್ ಇಸ್ ನಾಟ್ ಇಟ್, ಐ ಆಮ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಇಟ್, ಬಟ್ ಅದು ನನಗೆ ಬೇಕೇ ಬೇಕು ನಾಳೆ, ಐ ವಾಂಟ್ ಟು ರಿಟ್ರೀವ್ ದ ಇನ್ಫಾರ್ಮೇಷನ್, ದಟ್ ಕ್ಯಾನ್ ಬಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ಎ ಸೆಕೆಂಡರಿ ಮೆಮೊರಿ ಡಿವೈಸ್. ಓಕೆ, so these are some of the examples for input, output as well as memory devices. First let's see what are all the input devices. You might have already seen mouse, keyboards, everything in our early sessions as well as in your schools and colleges, and some of them which you might not have seen, that I am going to display it over here. These are the various kinds of joysticks which are available in market today. So you have a wheel based joystick, okay, you have 3-button joystick, okay, a very sophisticated joystick, you can move left and right. Sometimes you may not be able to move front, so you will be having one more joystick which will enable you to move front also. So these basically are used to play games. Okay, that is a fundamental, otherwise you can implement what I was explaining you, even virtual reality also. Okay, and this is another kind of input device which is called as a scanner. So what is the use of scanner? As I was explaining you, if you have some pictures and that should be stored in the form of a soft copy. What do you mean by soft copy? Soft copy andre ಕಂಪ್ಯೂಟರ್ ಸ್ಟೋರ್ ಮಾಡೋ ವಸ್ತುಗಳಿಗೆ ನಾವು ಸಾಫ್ಟ್ ಕಾಪಿ ಅಂತ ಹೇಳ್ತೀವಿ. I cannot call them exactly as a thing. The information which you are going to store inside the computer, they are called as that. You cannot physically touch and have the feeling, so they are called as soft copy. So even the photos, you have the hard copy in your hand, so you scan them and you are going to convert it in the form of ones and zeros and you are going to store it on the computer. It is called as soft copy. So this scanner is going to enable you to scan the pictures, as well as nowadays I was explaining you can even scan the documents also and store in the form of Word. Okay, you can store them in the form of documents. Later you can do some modification, you can give a new kind of printouts, you can format it and give. So they are called as scanners actually. So scanners will be working something like a light, beam of light will be flashing down. You are going to put a picture on that, so it is going to take the information. That beam actually is going to read the information, send it to the computer, so that it is going to store the information. Okay, so another kind of input device is actually a barcode reader. So what do you mean by a barcode? You might have observed this at the back cover of your any book actually. Anything or books has to be actually having an ISBN number. That ISBN number actually will be stored in the form of a barcode. Okay, so and when you go for shopping in some big bazaars, so everything has been barcoded, and whenever you take them, so they will be handling some barcode reader in their hands, and when they pass some kind of infrared rays on the barcode, the actual information will be read and it will be sent to the computer. So this is an example of barcode reader. It has got variety of useful nowadays. So how do you feel? So you have to enter the actual information. For example, one product, when very big product is there, Astarvis or something, one very big product, you have to enter its name. Okay, so along with that you have to enter the price also. Instead of doing all these things, so what you can do is you can store it in the form of a barcode, paste it on the product. As soon as you use the barcode reader, it is going to have the name as well as the price for you, and even sometimes they may have a discount also upon them. Everything and anything can be done in ease using barcode reader. This a typical look of a barcode reader. Just an example, you will be having barcode reader in variety of shapes when you go to a particular shopping area. Okay, so this now we will enter into something called as output devices. So we have seen input devices, some of them, and now we are going to see some output devices. Among them, the first and foremost one was the monitor, I said. So monitor will come in variety of ranges. Okay, you have 14-inch monitor. In the first place, analog monitor and digital monitor. In analog monitor, you used to vary the brightness and dimness using a wheel mover, but whereas in digital monitors, you are going to do this operation using buttons, push buttons. So then you have something called as TFTs. Nowadays they are called as flat monitors. What do you have? So then you have very huge monitors of say some 50 inches or 52 inches of kind. So various kinds of monitors you may encounter when you go out, okay, and see how a computer look like. These are some of the typical examples. Okay, you may have even color monitors, black and white monitors. Nowadays they are not manufactured because the difference might be around 100 rupees only. You by paying another 100 rupees extra, you are going to get a beautiful color monitors. Nowadays you are not going to find black and white monitors. Okay, so this is one more kind of output device which is called as a printer. Printer comes in variety of types. So as I was discussing Lippy printer, I didn't get a picture of Lippy printer actually. Lippy printer is the fastest what do you call it, dot matrix printer. Okay, dot matrix printer can produce a page at the rate of for 30 seconds one page, whereas line printer can produce as I was telling, in 30 seconds it can produce around 10 pages. So it is a difference between a dot matrix, but the output what you are going to get, the page which you are going to get printed on the paper will be in the same format compared to the dot matrix printer as well as the Lippy printer. The example for dot matrix printer is here. So this is the dot matrix printer, so which you are going to find it most often. Apart from that, you have two other kinds of printer. One is called as inkjet printer, wherein which you are going to use cartridges, okay, which will be in the form of in small boxes having ink. Whereas in laser jet printer, that is also called as cartridge, wherein which you are not going to have ink, you are going to have a powder. Okay, so the laser jet printer is going to heat, and you are going to get the imprint of whatever the document you are sending on a paper. So that is the disk jet printer. Okay, sorry, laser jet printer. So these are all the variety of kinds of disk jet printer that you are going to get in market. Actually, you are going to get 101 different kinds of disk jet printer. Laser jet printer also looks very much similar to this, except that the kind of printing material which is going to be used are different. Okay, hearing there is powder. Okay, so these are the some of the typical printers that you are available nowadays. Printers, they are integrated even with the fax machines also, and telephone. So everything is getting integrated day by day. Okay, so having 3 or 4 machines, you can have one machine and can do most of the work. Okay, so these are some of the inputs and output devices that we have discussed. Now let's move on to some of the memory. Okay, among them I am not going to discuss here primary memories, because primary memories will be in the form of chips. Okay, just static RAMs and dynamic RAMs which will be sitting inside the bonnet. So these are all some of the secondary devices which will be most often using. So among them, the first and the foremost was the tape drives. Nowadays it's not going to be used. Okay, rarely they are going to be used, wherein which you have to take the backups of huge amounts of data, and you are going to use it after some 2 or 3 months. That only we are going to make use of. That means the information which you want to take the backup, at the same time we are going to use it very less frequently. We are going to make use of tape drives. So they look very much similar to your audio cassettes. Okay, nowadays where do we find even audio cassettes also, isn't it? So the one major problem with these tape drives was, even though it was very popular earlier days to take the backups of huge amount of data, there is one organization, okay, don't know what happens tomorrow. At the end of the day, every data which has been done has to be collected and kept in one place. So tape drives used to serve the good purpose. One major problem is, once you store the data and it's got rewound to one side. So you want to access the first information which is stored on the tape drive, then you have to once again rewind it and use the that means it used to take some time. There is nothing called as random property of accessing here in tape drives. So they are excellent devices for taking the backups, but at the same time accessing the data wouldn't have been very much faster compared to your hard disk and floppy disk. Therefore they are going to find the they have gradually, even though today they are going to use in the place where the data is not important, but the data backup has to be taken. So only those places it's going to be used. Apart from that, we haven't found these tape drives anywhere nowadays. Okay, so then the second kind of memory devices, which were secondary memory devices, I call it as, very much useful, were floppy disk, isn't it? When they are introduced, they created a kind of revolution in which the data can be transferred from one place to another place. So earlier you used to get 5¼ inch floppy disk. It used to come very thin and having one 5¼ inch radius of disk inside, that would is magnetic disk, but it was very much unreliable. So then they made it bit compact, having the same information. See here, this 5¼ used to store the information of something like only some half megabyte of information. Okay, 512 kilobytes of information, whereas this floppy disk, which is 3½ inches, can store the information of 1.4 megabytes. So even though they are small in size, they could incorporate double the size of information compared to your they gradually replace these 5¼ inches. Okay, even now these floppy drives also we are going to use it very rarely. They are counting the days. Actually, the day have come wherein which you can use tape drives at least in some places, but people are not at all using the floppy disk nowadays. So this is a typical architecture of how a floppy look like. So basically it will be comprising of the main unit as this magnetic disk, the black color circular shaped disk what you are seeing, it is magnetic coated one, which is going to store the information in random format. So that will be revolving inside this top shell as well as the bottom shell. Okay, so So when it is rotating, you may develop some scratches. So to avoid that scratches, as well as it may absorb some dust also. So that's why we are going to have this kind of shielding protectors. Actually, the magnetic disc is going to rotate within these, so that it won't develop any kind of scratches, and you are not going to get any kind of, because these are act as scratch resistance as well as dust proof protecting layers for the disc actually. So then actually when you are carrying this floppy disk from one place to another place, you may be carrying it putting in your pocket. So what happens, this is the place where the information will be read from. Okay, you have a window slit here, okay, and through that the ray will be fallen, and you are going, there will be head nowadays actually. Earlier there used to be head. So the head used to read the information from this magnetic disk. So what happens, when you carry the floppy disk from one place to another place, what used to get happen is, so it used to absorb lots of dusts, and they used to be present on the magnetic disk, and causing lots of damages on the on actual disk. So that's why they use this shutter, when you carry, whenever you have inserted this floppy disk into the drive, this shutter will be open, making a way for the head to read the information from the magnetic disk. So whenever you remove the disk from the floppy drive, so it used to cover the slit, so that dust that won't get into the magnetic disk so easily. So they are called as shutter actually. Then you have stored some information. So these are some of the properties of floppy disk I am explaining. You have stored some kind of information, so and you don't want any other person to use that floppy drive. So at that time you can make it something called as write protected. That means you cannot write the information, only you can read the information from the floppy disk. That you can done using this. So another person, so it was not, I call it as something called a high security. Some person who is going to receive your floppy drive can simply open that write protect, and you can even write the information into it. So this is basically used to avoid some kind of virus. Earlier during 1995 to 2000, this virus problem was at its pitch. So at that time, whenever they used to send some vital information to the floppy disks, which were the mediums of sending the information, they didn't want those floppy disks to be get affected by viruses. So they introduced something called as Windows, in which you can protect a floppy disk from getting affected by a virus. Okay. So then we'll enter into something called as hard disk. Before I actually show you the architecture of hard disk, this is how a hard disk look like from outside. This is how the hard disk is looking like from outside. You might have seen it from various places. So and this is the internal architecture of a hard disk. Hard is a primary secondary device. These are all called as platers. Okay, they will be in circular shape. Okay, and you will be having 3 to 4 platers, and this architecture, see, it has got 3 platers, and both sides you can store the information. They are coated with magnetic material, and if you see from above, so these are actually circular disks. Okay, so if you see from above, don't think that you are going to get these circle sectors and all. So basically you will be finding only a very plain hard disk over there, but actually internally it's going to get divided into something called as these are called as cylinders, what do you call it, as tracks, and each track is divided into many number of sectors, and a track which are present at the same time, same parallel area, they are called as going to be called as cylinders. Okay, so this is a head. Actually head will be moving either forward or backward direction. Head is not going to moving either upward or downwards, it just simply moves forward and backward. So whenever you want some information, for example this track information you want to read, so at that time what happens is this head will be moved to this particular track, and this sector will come and exactly sit below this head, and you are going to read the information. So how do you actually do it? That's going to be written through something called as device drivers. So this is a typical architecture of hard disk. So hard disk, these are called as platers. Platers are divided into number of tracks. The circular shaped ones are called as tracks, and each track is divided into sectors. Okay, and the disk move in revolution clockwise, anti-clockwise direction, whereas head is going to be moved front or back. Okay, so the head will be moved to the corresponding track, and a sector will come and sit below that track, and you are going to start reading the information. This is a typical architecture of a hard disk. Okay, So this is how we are going to look the hard disk from outside. You can hold it and see it, whereas this is the internal architecture of hard disk. Okay. So hard disk was heavier, as well as once you fix it, it would be very difficult. I can't call it impossible, because you can remove the hard disk and place it in some other things, but the thing is it was impractical to move the hard disk from one place to another place, and so that's why they introduced something called as flash drives. What do you mean by flash drives? Flash drives have the capacity of some 1 GB, 2 GB, even up to 10 GB also nowadays. So you can store the information, what you secondary information, take it from one place to another place. So this is an example for flash drive actually. So you might have already seen it many times. And one more kind in which you can store the information and take it wherever you want. Okay, movable disk is compact disk, CD, and you have something some other thing which is called as digital versatile disk, what we call it as DVDs. Okay, DVDs are most often used to store the video. So DVDs, if you ask anybody what is the expansion of DVD, they say digital video disc, but actual definition for DVD would be digital versatile disc. Okay, what is the difference between this is CD and DVD? May look very much similar in shape, but the color you may find is bit blue color. So the difference between CD and DVD: CD you can have 800 MB of information, whereas in digital versatile disk you can store 4 GB of information. That's almost equal to 7 times the information you can store it on compact disks. So digital versatile disk can store more information. Okay, so and nowadays they have identified one more technology which is called as BRDs. You might have already heard this. They are called as Blu-ray discs. The ray which is going to be used to read the information is bluish one. That's why they are called as Blu-ray discs. Because of some standard mismatch between the companies which have produced the Blu-ray disc, they are not released into the market till now. If the one Blu-ray disc can store information around 10 GB, that's almost equal to 2.5 times compared to your digital versatile disc. Okay, so they are not at in the market. They are to be just heard as terminologies. Okay, so till now we have seen what a hardware is, and as I was explaining you, hardware is a part which you can see by touching and having a feel of it. Then what do you mean by software part of a computer? Software is nothing but the lines of code which you are going to write and make the computer to execute one after the other. Okay, so they are put simply as lines of code. So as that's what, when you define a computer, it says it takes the information, process it according to a set of instructions. Those set of instructions are nothing but software. So that we have to user have to read, user have to write and give it to the computer, so that the computer is going to execute them one by one and give the desired results. Okay, so when you come to the software, actually you can develop two kinds of software. One is called as system software, the other one is called as application software. Okay, system software, if you want me to take an example, it's an operating system upon which your computer is running, or it can be a compiler, assembler, something using which you develop some other softwares. So that some other softwares are called as application software. So the system software gives the basis of other kinds of softwares. So they require huge brains, very much mind crunching activity you have to do to develop system software products. Whereas application software, for example, your Visual Basic is actually, when developing, it's a system software. After that, when you are using it, will become an application software. A compiler is a system software, but a compiler is used to compile the program and see the outputs. Okay, so those outputs are called as application software. A word processor actually is an application software using which you are going to, but the editor which is sitting beneath that word processor is actually a system software. So that is the major difference between system software and application software. System software are written once and kept, and people are going to use that system software in many occasions and many varieties to develop application software. Okay, so when you come to system software and application software, is one kind of differentiation between the software which you are going to develop. Then one more kind of division on system software is software is open source and proprietary software. So what is the difference between open source and proprietary software? ನೀವು ಒಂದು ಕೋಡ್ ಡೆವಲಪ್ ಮಾಡ್ತೀರಾ. ಸೊ ಆ ಕೋಡ್ ಡೆವಲಪ್ ಮಾಡಿ ಅದನ್ನು ಕಂಪೈಲ್ ಮಾಡಿ, ಓಕೆ, ಅಥವಾ ಅಸೆಂಬಲ್ ಮಾಡಿ, ಲಿಂಕ್ ಮಾಡಿ, ಫೈನಲಿ ಒಂದು ಎಕ್ಸಿಕ್ಯೂಟಬಲ್ ಫೈಲ್ ಅಂತ ಕರಿತೀರಾ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೈನರಿ. ಕೋಡ್. ಆ ಬೈನರಿ ಕೋಡ್ನ ಮಾತ್ರ ನೀವು ನಿಮ್ಮ ಕ್ಲೈಂಟ್ ಕೊಟ್ಟರೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪ್ರೊಪ್ರೈಟರಿ ಸಾಫ್ಟ್ವೇರ್, ಬಿಕಾಸ್ ಯು ಡೋಂಟ್ ವಾಂಟ್ ಯುವರ್ ಕ್ಲೈಂಟ್ ಟು ಸಿ ವಾಟ್ ದ ಕೋಡ್ ಆ್ಯಕ್ಚುಲಿ ಯು ರಿಟರ್ನ್. ಯು ವಿಲ್ ಆಸ್ಕ್, ಯು ವಾಂಟ್ ಯುವರ್ ವರ್ಕ್ to be get done, that's it, and I am not going to give you how I developed it. So that is called as proprietary software. Whereas in open software ನೀವು ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಬರೆದ್ಬಿಟ್ಟು ಅದನ್ನ ಇಂಪ್ರೂವ್ಮೆಂಟ್ಗೋಸ್ಕರ you are going to put it across the net or wherever it may, we are going to distribute among other educational institutions, you are going to share it with your friends so that they will also suggest some improvements. ಅದು ನೀವು incorporate ಮಾಡ್ಕೊಂಡು you are going to grow. So they are called as open source softwares. So nowadays people are giving much and much emphasis towards open source software, because they receive the software and they are going to tune it to whatever the needs they want. Okay, so that is the difference between open source and proprietary software. So ಇವಾಗ ನೀವು ಒಂದು ಗೇಮ್ ತಗೊಳ್ತೀರಾ, ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ತೀರಾ, that will be a proprietary software. You won't get the source code, how they develop the code you never get it. So that is called as proprietary software. Whereas ನೀವಾಗ ಒಂದು Unix, and nowadays you are using one operating system which is called as Linux. In Linux you are going to use one game, but that game they are going to give even the source code also. For example, if they have developed that using one C language, they are going to give the entire source code to you, so that you can change the appearance of that particular game, you can use it. But one thing is, when you are receiving the open source software, you have to give it back to the community free of cost. When you are receiving something free of cost, you cannot expect it to sell it also, sell it for some money. Okay, you have to give it free also. That is what the open source community they are going to say it as. Okay, so when you are purchasing, that's what I was describing, when you are purchasing the license of a software, when you are purchasing a game, you have two kinds of when you are purchasing, for example, a word processor, you can purchase it in two ways. One is called as source license, the other one is called as binary license. So the source license will cost you 10 times compared to the binary license. Binary license ಅಂದ್ರೆ just executable file ಕೊಡ್ತಾರೆ. ನೀವೊಂದು ಲೆಟರ್ ಟೈಪ್ ಮಾಡಬೇಕು, ಅದಕ್ಕೆ ಒಂದು ಎಡಿಟರ್ ಬೇಕು ನಿಮಗೆ ಲೆಟರ್ನ ಟೈಪ್ ಮಾಡೋಕ್ಕೆ. ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ವರ್ಡ್ ಪ್ರೊಸೆಸರ್ ಬೇಕು. ಆ ವರ್ಡ್ ಪ್ರೊಸೆಸರ್ನ ನೀವು ಬೈನರಿ ವರ್ಷನ್ ಅಂದರೆ ಜಸ್ಟ್ ಕ್ಲಿಕ್ ಆನ್ ದಟ್ ಐಕನ್, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದ ವರ್ಡ್ ಪ್ರೊಸೆಸರ್, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದ ವರ್ಕ್ ಡನ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೈನರಿ ಲೈಸೆನ್ಸ್, ವೇರ್ ಇನ್ ವಿಚ್ ಆ ವರ್ಡ್ ಪ್ರೊಸೆಸರ್ ಹೇಗೆ ಡೆವಲಪ್ ಮಾಡಿದ್ದಾರೆ ಅನ್ನೋದಕ್ಕೆ ಫುಲ್ಲು ಡೀಟೇಲ್ಸ್ ನಿಮಗೆ ಬೇಕು, ಸೋರ್ಸ್ ಕೋಡ್ ನಿಮಗೆ ಬೇಕು, ಯಾವ ಲ್ಯಾಂಗ್ವೇಜಲ್ಲಿ ಡೆವಲಪ್ ಮಾಡಿದರೆ ಎಲ್ಲ ಬೇಕು. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸೋರ್ಸ್ ಲೈಸೆನ್ಸ್. ಅವಾಗ ನೀವು ತುಂಬ ದುಡ್ಡು ಕೊಡಬೇಕಾಗುತ್ತೆ, ಯಾಕಂದರೆ ಅವರು ಕಷ್ಟ ಬಿದ್ದು ಸೋರ್ಸ್ನ ಡೆವಲಪ್ ಮಾಡಿರ್ತಾರೆ. ವೆನ್ ದೇ ಆರ್ ಸೆಲ್ಲಿಂಗ್ ದೇ ಎಕ್ಸ್ಪೆಕ್ಟ್ ದಟ್ ಮಚ್ ಕಾಸ್ಟ್ ಓನ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಸೋರ್ಸ್ ಲೈಸೆನ್ಸ್ ಆ್ಯಂಡ್ ಬೈನರಿ ಲೈಸೆನ್ಸ್. So these software can be produced using variety of languages. So what is this language? Basically, language is nothing but the way in which we communicate the information, so computer has got different languages. So when it comes to the languages itself, we are going to have the languages in two different format. One is called as natural languages, the other one is called artificial languages. So what is natural language? Natural language anta helidre the language which we use to communicate from human to human. So maybe Kannada is a natural language, okay, Hindi, Tamil, English. So they are called as natural languages. Whereas artificial languages which we use to communicate with the computer. So artificial languages includes assembly language, okay, they have C, C++, basic, COBOL, everything they have. So natural languages I don't want to give much emphasis, because that's not the topic to be covered today. What are artificial languages? Artificial languages which we use to communicate with the computers can themselves be divided into three branches. One is called as machine level, that will be in the form of ones and zeros, 1 0 0 0 1 0, but we are not going to understand it, the machine is going to understand it. Then second is assembly language. This is a second level of writing the here instead of having ones and zeros, you will be having something called as mnemonics. For doing addition of two numbers, you say add n1 comma n2, add operand 1 comma add operand 2. For multiplication you have mul, that is mul r1 comma r2, something like that, but you are not going to give a complete line, okay. Whereas high level languages, they are going to write the instruction in the form which even can be understood by a human being also. For example, in C language, to print a message hello world on the screen, you are going to say printf within double quotes hello world. So anybody who is going to say that anybody who is going to see that statement will immediately come to know that this language is trying to print hello world message on the some device, okay. It may produce it on a monitor, it may produce it on something else, that's not, but he comes to know that it is basically used to display some message. So okay, they are called as high level languages. High level as machine level language you cannot understand it. So assembly language 8086, 8085 you can write assembly language programming. Whereas high level language programming they initially started with BCPL, followed by Fortran, basic formula translation. Fortran is expanded to basic is beginners all purpose symbolic information code. Then COBOL they invented a common business oriented language. Then they introduced C, which is revolutionized the way in which the softwares have been written in the industry. Okay, followed by C++, which is one more era wherein which started developing something called as object oriented programming. Okay, so which language to learn, it is up to you actually. If you ask me now which language to speak, in one area you are present. So if you are in Karnataka, speak the language Kannada. If you are in Orissa, speak the language Oriya. If you are in US, speak the language English. Okay, like that. So which language to learn here, so depends upon your work basically. So wherever you work, if they ask you to code it in C, you learn C and do it. If they ask you to do it in Java, learn Java and do it. So this is the concept of hardware and software in computers. So let's get back to you with more and more information regarding software and hardware. If you have any problems, please mail us, okay, and we'll be very much interested to interact with you. Thank you very much.